Hello guys, my name's Kuru and today we're going to be looking at something that's known as fatigue. So let's start off with a question here. What is fatigue? Well, to put it simply, fatigue is the act of an object giving out due to repeated stress and a repeated amount of cycles. And we're going to be looking at two types of cycles today in specific. We're going to be looking at 1,000 cycles and 1,000,000 cycles, and that's usually what you'll see on an SNN curve at the 2 points where it's marked clearly, and then in between that or beyond that, it's just an estimation. So how do we draw an SNN curve, you might ask? Well, there's three things that we need to draw the curve. We need to calculate our SU and SF, we need to calculate our correction factors, and we need to calculate our corrected factors. So basically, looking at this little graph here, what we're looking at here at the very first point is the cycles, 1,000 cycles, 10 to the 3 cycles, right? 1,000. And the value for this amount of cycles is also known as SF. And SF is the amount of stress to cycles, the ratio between that. And it's basically showing that value for 10 to the 3 cycles. Now, if we move down the ladder here, we're going to see the amount of cycles at 10 to the 6. That's 1,000,000 cycles. And the value for that is going to be your SN. And your SN is calculated through a combination of things. Specifically, you're going to need over here, you're going to need your SN prime, you're going to need your CL, you're going to need your CG, you're going to need your CS, you're going to need your CT, and your CR. And we're going to explain how you can derive this and actually get it pretty easily from a table and graph in the next slide here. So next topic here is how can we use charts and tables to find these coefficients? Well, glad you asked. CS can be found using a graph in which the variables hardness, tensile strength, and the variable of material surfaces are necessary. And basically, this graph, it was actually seen on our midterm a couple days ago. And basically, what you're going to do is you're going to find either the hardness or tensile strength. You're going to locate that on the x-axis of the graph. And the next thing you're going to need is your the surface material condition. So I don't know if it's machine polished, that's one example. And let's say it's machine polished, right? So you would locate where exactly this hardness or tensile strength would intersect with the machine polished curve, and basically that corresponding intersection would be where your CS can be found. And next up we have our CL, and the CL can be determined from a table, and it's based on the type of load. And for the SNN curves, we have three major types of loads. We have bending loads, axial loads, and torsional loads. So based on that load, you're going to get a different value for CL. However, bending and axial do have the same value, so that's something to keep in mind. CG can be determined by the object's diameter and the type of load. CT can be determined by the temperature of the testing conditions. Usually it's under 50 degrees Celsius, so that would be 1. And from the table that's provided, we only get the values for steel. So there you go. CR can be determined by the reliability factor given in the problem. So for the midterm, I don't know about you guys, but I had a reliability factor of 50%. So if we look on the table that is provided in your examinations, you'll be able to see that for different percentages, there's different factors for each load type. For bending in specific, there's a value available for axial or torsion. So, for example, let's say my reliability was 50%. Then my value for the CR would be 1. So that's my corresponding value for CR. In the scenario, my reliability factor was 50%. So next up, we're going to see how we can estimate the number of cycles for a certain applied stress. So to find the stress factor on the SNN curve is actually pretty easy for the number of cycles. You're basically gonna find the number of cycles you want to know the stress factor, or you're gonna find the stress factor you're looking for. So let's say I want to know how many number of cycles am I gonna expect at like 600 MPa according to this table here, or my fault graph. So all I'm gonna do is I'm gonna look at where 600 is. I'm gonna see where that intersects with the curve. I'm gonna go straight down, and as I can see, it's somewhere around 10 to the 5. Obviously, that's not exact, but you get the idea. It's pretty straightforward there, and that's the basic idea when it comes down to estimating the number of cycles for a certain amount of applied stress. And yeah, that's the end of my presentation. If you have any questions, please let me know. You have my email somewhere on Avenue, and you can let me know if you have any troubles. Thank you, and I hope you enjoyed this presentation.